Hi, this video is meant as a little showcase for an application of Tekla Structures that automates the detailing of lifting anchors for precast wall elements. So usually when you do precast design, you need to add lifting anchors for your walls and all other elements, of course, to be able to transport them from the factory to the site. And how big these anchors need to be is usually based on information about the wall element itself, like its area, its weight, and so on. And basically what we can do is, since we already have this information in Tekla Structures, we can create an app that takes this data from Tekla Structures. Then it does some calculations in the app based on, let's say, the manufacturer's catalog, the manufacturer of the lifting detail. And then when it has the result of it, it can simply insert the required lifting detail inside the Tekla Structures model. So to show you how this works, I have a test model here. As you can see, none of these walls have anything in them. So what we simply do is we select the walls in which we want to add the lifting anchor detail. We bring out our application and we check whether these parameters are good for us, for our factory, for our company. This works, since there are some variables from the that come from the manufacturer's catalog. We check whether these work, and we simply press insert lifting loop. And this inserts lifting loops in all of the elements, all of the precast elements that we had previously selected. And they are, you can see, for example, we have this bigger wall. We check it, it now has two 10-ton lifting anchors. And if we check this wall, it's lighter, right? We have a 7.5-ton one. So this particular application, it's done in using Tekla Structures 2020, and it uses the Terwa lifting anchors, specifically the SATTU one. If we go to SATTU, in the catalog is also the full description of how one would calculate these anchors for all specific cases, for all specific use cases, right? And this is what we've also based the calculation on this anchor, but they are the same pretty much for all of the manufacturers of this kind of lifting inserts. This is the same. So this is not it. This is, yes. So SATTU anchors, and there's a bunch, right? As you can see, and all of them have a different capacities and then quite a bit of information upon which the choice is based on. But in our code, we are able to capture all of it. So this code is it's a very basic .NET form application that uses Tekla Structures Open API. We've created a form here that you saw previously as well, here, actually working. We've created this form where the user can input parameters that he likes. We have some automatic calculations here of what that actually means for the calculation. The user input, what it means in terms of numbers, right? So if we just go through the code, we initialize the form, we set some default parameters, right? Something to start with. Then we've created this this class called Terwa SATTU, which is where we put all the information regarding the lifting anchors in. So we've inserted all the types here and added their capacities as well, their names and so on. So I think it's 9 anchors or something like that, 9 types. Then we have the calculation of the anchors. Basically, we create functions that where you input certain numbers, like for example, what will be the force in the anchor and some other parameters, and it is simply able to tell you which of these anchors you need to choose. And basically, iterates starting from the weakest going to the strongest. So it checks whether this works, whether this works, whether this works, whether this works. And when it finds an anchor that it works, it just stops and says, okay, this is the one you need, right? And when you're calculating the walls, what matter are two type of loading types, right? One is when you pull it. So basically, one is when you have an element like this and you simply pull it up, right? And a second one that you kind of matter for these inserts is when you tilt it. So you have the element laying on your formwork, and you have your lifting anchor insert, and then you have your chain, and you pull this way, right? And these are the two calculation types that you usually do for these lifting anchors. So this is here, yeah, calculating pull detail, calculating a tilt-up detail. So we have, yeah, these functions will help us determine, based on the already gotten parameters, what kind of detail we need to insert. After that, we have some helper functions that just help to set up these parameters that I showed here. Basically, these based on what is happening here. If the user changes one of these controls, this automatically changes. So those helper functions are for that. Then we have the classic check if model is connected. You just check if Tekla Structures model is actually connected right now, and then we can interact with it. We have a function that checks whether the things that we selected are actually usable, if they're parts for this in this example. Then we have some functions that calculate those two types of forces that I showed previously, the pull force and the tilt up force. We have those, and those basically, yeah, they are. Yeah. Then we have the insert button. This is all the code for executing anything we have put in this insert button, because all the good stuff happens when we press this button, pretty much, right? So if we check this was there, we start off by checking if model is actually connected or not. Then we check whether the selected objects are to our liking. In this case, we check if there are only parts there. If not, we simply return. And in both of these functions, previously we also did some error messaging as well, so the user understands why the component does not work, or the yeah. So after that, we take the list of the objects, right? Then we iterate through the list of objects, picking one object at a time. This is what this for each loop means. We get the list, and it's actually parts, right? It's individual parts, because we want to insert. In the end, we want to insert in the part, because then it will sort of work. If you change the part, then it will automatically follow suit. But for calculation wise, we don't want only part. We want to have the assembly of where the part is, because if we do a sandwich wall, for example, later on, then we need the data from all of the layers, right? So we need the layer the weight from outside leaf, from insulation, and from the load bearing leaf as well. So with this, we simply just get the assembly of that part, right, that we had selected beforehand. Now we get the parameters from Tekla Structures for each of the elements, right? So we get the weights, we get the length of it, we get the area projection, x, y net. So basically, in Tekla Structures, x, y net. So whatever sort of contour plate or wall element, any panel will have a, so if it's like this, all of the panels will have always, I hope that I'm drawing it correctly, but all the panels will always have x, y in the plane. That was terrible. X and y in the plane, and z to the outside. So we need this area to calculate the adhesion factors of the molds of the formwork. Then we get the main material. Basically, some of the calculation parameters were also taken into account the strength of the concrete. And what basically we're doing here is we are assuming that at least 37 concrete, 70% capacity will be used. But if there is an actual material here inside part, so settings, like here, then it will actually take this data, not assume something. So then we're taking those numbers that we had here, right? And we're doing our calculations. We have set up to one function and one method. Basically, from one side we calculate what is the force in the anchor part, and we do that based on all the data we had previously collected. And this is the function that does that we previously had made up. And after that, we will input this into the method that we previously wrote to get the actual detail. And then here we have initiated a object based on the class that we wrote previously, which was the class was Terwa SATTU. And then we say, okay, so this we will use that, and we create an object from the class. And then that class contained some methods that we had written, and one of the written methods was calculate tilt of detail, and we calculate what kind of detail we need for demolding and tilt up at the plant. Then we go to the second use case, which is calculate the force and anchor for transportation at the plant, and for transportation at the plant. It's the same sort of setup. Of course, these are different. And then we have a calculated force and anchor for transportation at site also. So these are the 3 use cases. Put them all together. So these functions will basically return indexes. Because in the class, what we had done was we had put in multiple items, let's say items, multiple hashables or dictionaries if you're a Python user, maybe easier a little bit. We had put them in a list, right? So when we check for what kind of anchor we need for each of these use cases, we return a index. So we have the index starting from the lowest, going higher, higher, higher. So then we just check what is the minimum, what's the smallest of the indexes, and we had set up the functions so that, or the methods, so that if they cannot give back a valid result, they return -1. So we just check if a -1 is returned. If a -1 is returned, it means that for that particular use case, no anchor was usable, right? So if this check would have a -1, it would mean that, hey, one of these transportations, either at tilt up at factory, there is not big enough detail for that, or a transportation pool in factory, or transportation on site pool, that the loads are too big for these anchors to handle, and generally we need to have at least something. We cannot work with -1 here. We need at least some index, right? So this just checks whether you can actually even lift the element. But if we're all good and we got an index in each of these types, and then we just take the maximum index, because that is the worst case, that is the biggest anchor, and we prepare a string with the name of the anchor type. So basically what that are these strings, right? So we prepare that, we output basically. What the whole thing does is just it outputs this particular name. And why is that important? That is important because now we want to actually insert the detail in Tekla Structures. So to do that, we are going to be using a little bit different component. It's called lifting anchor. It has some nice functionality. It's a system component done by Tekla Structures themselves, like this. And you can insert custom components through it as well, different settings. But it has some nice functionality, like it finds the center of gravity, also adjusts heights. Oh, it's just a good component overall. And we don't want to rewrite stuff. So as you can see, it's inserted this component with some settings here. So basically, then we just set up this new component. We give it component input, which is the part object that we are currently checking, right? Then we set up some data for it, some attributes, and here we insert the name that we previously got, this string, right? And then we just say, okay, just insert it, right? Insert the thing, insert the lifting components. And what this will basically do is actually just set up this component with set up this component. I can show you here. It's going to be better. With in this field, it will put what the string that we gave for it. And if you tag the string, you can see that there are actually pre-made components with these names. So the components are super basic. You know, it's the actual lifting detail. If you were to write here SATTU, then these are the components. And these get inserted, or rather, the lifting anchors component get inserted, and it automatically inserts these as subcomponent. These I will actually add, I think, to this video, these components, because well, in the official warehouse, Terwa has published their anchors. They have done it as items which are non-solid. So if you were to insert these, you will actually break a lot of, well, some of Tekla's functionality, and some things will just straight up stop working because this is yeah, you can see I have them here, right? But the problem is they're non-solid, so yeah, as soon as you attach them to a assembly or a cast unit, they will just break that thing, and then a lot of things will just stop working, and a lot of data will not be reported anymore. And some of it is actually used by our application. So yeah, I've just really hastily put together my own components, and I think that you should do this as well if you start developing something similar to this. So generally, that is all. There is nothing really else to this. Yeah, just commit changes, and down here there are some data that adjusts the fields if the combo boxes are changed, meaning that data that changes this if this gets changed, right? As I previously said, this is we'll open this up really quickly. So yeah, so basically these get changed, right? And that's really there is to. There is nothing else that much. I will actually upload this to GitHub, and I will have a link with the video. This is based on Tekla 2020. If you need to do it for a different Tekla, you actually just basically open up the application with Microsoft Visual Studio, and here where you have NuGet Package Manager, you can see I have installed this 2020.03. This is what works for me. Basically, you take the code, you put it on your computer, you uninstall what I have here, and just install what you need if you have a different version. And for most part of it, I think it will work, especially with 2021 and so on layer. So it should not be hard to get this portable to different Tekla versions. So hopefully something like this works for you, and you can try to use this or use it as a basis. There are a lot of things you can go on and actually customize about this and make it a lot more better. But this is, as a first working prototype, I think pretty decent start to automating stuff that really should be automated inside Tekla Structures. So cheers and see you on next videos.